Goody.
Okay, so equations of straight lines. So, vertical and horizontal lines. Now, we did start looking at y equals c, didn't we? Yes. But we're kind of sidestepping a little bit and looking at, in particular, vertical and horizontal lines today. So, gradients of vertical lines. Do you remember how we said how we described their gradient of a vertical line? What's the gradient?
Zero.
No, not vertical. It's nearly nice. Okay, do you remember that? So a vertical line has an undefined gradient. A horizontal line is zero. Yes. Okay. So gradients of vertical and horizontal lines, they'll be different colours. And so horizontal lines have a gradient of 0, and vertical lines have undefined gradient. My board's dusty, I can clean it when I'm right. Alright, so their gradient is undefined. Now, if I was to plot the following coordinates, let's try it, shall we? So, I would like you to draw. I know the answer. Okay, hang on. Should we just give it back? Just humour me. So, can we plot these 5 coordinates and join them up in one colour? And then plot these 4 coordinates, join them up in a different colour, and so on and so forth. So we have 4 different coloured lines.
I always put it in the first one or after the second one.
So alphabetical order, X before Y. Okay? So if we're plotting the point 2, 4, assuming that each one of these squares is 1, okay, so we haven't actually labelled it, but assuming each one is 1, the coordinate 2, 4 would be here. There. Okay? Mine went a little bit too weird. 2, 1, 2, 3, 4. Actually, it's here. Okay? So you're going to plot those points for me in different colours and join them up. And then we're going to have a little chit chat about them. Right, so hopefully you've drawn all your lines. Now let's have a little discussion about this. So let's look at all of these coordinates for line 1. Do you notice anything special about the coordinates for line 1? Gabby? Right, all the x coordinates are the same. And what do those x coordinates happen to be for that line? 2. So here, all of the x values are 2. Okay? Now let's have a look at the line. Where is the line? We should have found that the line should have looked something like that. Yes? And they've all gone through this point here because they all have an x coordinate of 2. Now, that actually indicates to us that if we were to ask you to draw the line of x equals 2, that's what it would look like. Because all of those coordinates have the x value of 2. The y value is neither here nor there. They would always sit on that line there. So, x equals 2 would be this line here. Let's have a look to see if that worked for any of the others. Alright, the second one. Okay, so my second one I'm going to say is red. So, we should have noticed, or hopefully we can see now, that all of the x coordinates are -3. So, establishing that -3 is over here on the x-axis, we should have found that they all form a line looking like that, yes? So this would be the line x equals -3. Haha, she cried. So let's look at some of the others. What do we notice about line 3? Good. So the y value is 3. So what do we think the line is going to do, or what did we find the line did? We should have found it went horizontally through the value of 3. What do we call this line? Y equals 3. Oh, tell you, we'll make mathematicians ugly yet. Our last one.
You know green and purple?
That's what I picked.
Oh.
Is negative 4. And so we should have drawn a line through negative 4. And that's why. Just the ends, yes? And so I think sometimes this helps just to make you understand why, because you've got those coordinates. It's called the line x equals 2 because the x coordinate is always 2. It's called the line y equals negative 3 because the y coordinate is always negative 3. Okay? Can you predict what the equation exam would be? Yes, we did that. So go back to our little summary on the next page. So it says vertical lines. These are, that's really good England, these all have an undefined gradient and have the general form of, what did we say that the vertical lines both started with?
What?
Sure?
Undefined.
It was 50-50.
Undefined.
And darling, we talked about the gradients, undefined gradients. If we were to describe it, it would always be x equals a number.
Wait. But horizontal isn't that for like everything here, right?
Correct?
That's x.
Now, that's the x-axis. We just went through this. Do you believe me when we did it? Turn back a page. Yeah? So look at where all the coordinates, the first line, the x value was always a 2. Yes?
Oh yeah, sorry. Yeah, I know now. I'm fine.
Sure?
Yeah. Wait, Miss Harrison, isn't it like for x equals a number? Isn't it like for it always? It's like always a number.
So e.g. x equals 7. Or x equals negative 1. No. Yeah, sure.
Okay.
So if it's a vertical line, it's not y equals mx plus c is what I'm trying to make sure you're not getting confused with. So when it's a vertical line, it's just x equals whatever number it goes to. Okay? So to find the equation of it, you look to see which number it goes to on the x-axis, and that tells you what the equation is.
Okay.
Yes. Danny and Haley, stop talking. Now, let me talk about the x and the y-axis in a minute. So vertical lines all have the equation of x equals a number. Horizontal lines, these, you see how complicated. These all have a gradient of 0 and have the general form of y equals a number. E.g. y equals 3, y equals 3. Okay? So that's our two basic horizontal and vertical lines. So let's have a look at this diagram here and make sure that we can establish what the equations of these lines would be. Okay? So, I don't know if you want to label them on top of them or do a little key next to them. But I'll give you a couple of minutes to do it. Do I need to do one with you? Okay, so I'll give you a couple seconds. Alright ladies, so we're going to go through these now. Now I don't know how you label them, whether you just colour coding or numbers. It doesn't, well no, I'm just going to do them as I get to them. So we have to remember that our horizontal lines always start with y equals. So this top one up here would be the line y equals 7. Oh, I got that. Okay. This red one here is the line y equals 3. This yellow one is the line y equals -4. So far, so good.
Yeah.
Okay, so they're my horizontal ones. I'm now going to move to my vertical ones. So this green bad boy here, what all the vertical ones start with? X equals. So x equals what, Hayley?
X equals -6.
Lovely.
Oh,
Whoa. This blue one would be what, Elsa?
blue one is x equals -2.
X equals -2. Lovely, jubbly. And this orangey, reddy, whatever colour this bad boy here is, Cheyenne?
X equals 8.
X equals 8. I'll believe you. Okay, we all good with that? Brilliant. Now, here this is where I'm going to about the axes. Now, this is what throws people into a bit of a tailspin. Because the x-axis is a horizontal line. Okay, so that's why people often get it mixed up. But the best thing to think of is the opposite of what you think. Right? So that even though the x-axis is horizontal, those lines, the horizontal lines, are y equals something. But what it does mean is that the x-axis also has an equation of a line. The equation of the x-axis happens to be y equals 0. So the x-axis has an equation of y equals 0.
The equation for finding a straight line.
The equation of that line. So if you had drawn a line across here and someone had asked you what the equation of it is, you would have to say y equals 0. You could not say it's the x-axis because that's not an equation.
Yeah, okay.
So equations have to have equal signs, yes? And this x-axis has the equation of y equals 0. But the y-axis is a vertical line. So what do we think his equation is going to be? Cindy?
X is equal to 0.
X is equal to 0. And again, it's, I don't know if it's easier or not, just think of it as the opposite of what you think it should be. Okay?
And something that can you also consider is like where the line intersects on the x with the y?
Totally, yes. I mean, and that is the reason it is x equals 0 and y equals 0. But we just have to remember we call it the right one. So whilst the x-axis is the equation, y equals 0. Okay, yes? Right. Now, if asked to plot or draw any kind of functional graph, okay, any, whether it's a nice, basic, straightforward straight line, or if it is a trig graph, or if it's some really fancy equation, you can always use this method here that we're going to talk about. Basically, you're going to set up a little table of values. We've talked about this briefly already. You can choose some x values. If they've given you some x values, you're obviously going to use those ones. But if they've given you a blank canvas, then you can choose any value. Okay? Now, as I've said here, to do this, I would recommend a minimum of 3 points. Okay, so you're going to choose a minimum of 3 values for x, and I would include one of them to be 0. Right with you. Okay, the reason being is that if you have x at 0, then you're going to know what happens to it when it crosses the y-axis. Okay? So once you've chosen your values, you then substitute them one by one into the equation or the rule that you've been given. Okay? That's going to then generate a y value. Okay, so that's going to give you a y value for that particular value of x, and then you're going to plot them as coordinates. So here's my graph that I need to draw. Draw y equals 3x minus 1. So we're going to choose some random values for x. Now, I would always suggest you kind of look at your scale on your graph. Now, I have got no numbers on here as yet, and that's on purpose because I'm going to choose my numbers first. When you're generating your x value, choosing your x value, I would say minus 51 points. That's it, done.
-4.
So I would go for smaller numbers, okay? If you need to find an additional one because you don't need to go graph, then you can do that. But I would go with small numbers. Right, so what do you want to do then?
-4.
-4. I've suggested that you always have 0 as one of them. Sydney? 6. Okay, there's my 3 coordinates for now. So we have chosen our 3 x values. We're now going to substitute them one by one into that rule. Erin, what's the rule?
3x minus 4.
What does that mean we're going to do to the value x?
We are going to multiply by 3 and then -1.
Correct. All right. The 9. Can you do that with the first value, please?
I understand.
You don't understand? No. Oh, okay, that's good. Because I hope it can help you understand. So, Erin told me that this rule here means we're going to multiply our value x by 3 and second one. So you're going to take this first value that we chose as a class, and you're going to multiply it by 3 and take away 1.
-13.
Good. So we're going to write that number in there. Okay? Done. Oh, that's easy. So what's 3 lots of -4? What is it?
12.
Equally,
-12.
and then we're taking away 1. Yeah. Right. Haley, in the next one for me. Then. Good. 3 lots of 0 is 0, so 1 and 1. And then our last one in this round is lovely jubbly. 3 lots of 6 is 18, taken by 1 and 17. Now, these are pretty big numbers that you chose. It's okay. We can just make sure we draw our scale so we need to make sure our x's go at least between -4 and 6, and our y values have to stretch between 17 and -13. So this is a common situation that we have to look at graph paper, and we need to decide what our scale is going to be. You're not always going to be able to say, what scale do I use? How often am I? Is it every 1? Is it every 2? You often have to make that decision. Okay. So I know that 0 is in the middle for both. So what's the good thing to go up that you need to reach 17? So we've got 2, 4, 6, 8, 10 squares here. So 2 for each baby one. Okay, so 2, 4, 6, 8, now we need to make sure we continue that scale going down. So this is going to be -2, -4, -6, -8, -10. That'll do. And then take more. Oh, okay? Now, this is where some people will again get a little bit stressed out. The horizontal axis does not need to be the same scale as the vertical one. So we've got each baby square is worth 2 in the vertical axis. You do not have to have the same scale in the horizontal. So we only need to stretch between -4 and 6. So I'm going to actually have each of the red squares as 1. So every 2 squares is going to be my 1. Now, I would always suggest, as I have just labelled, start from the middle. Okay, so I started with 0. I went out 2 squares, 2 squares, 2 squares. I went back 2 squares, 2 squares. Because I've seen so many times people will only leave a gap of 1 here or something, and it just all makes it very horribly wrong. When you're first of all writing this, make sure that you're doing everything in pencil so it's not white out crazy. Okay, so then we start plotting them as coordinates. Now, what I mean by that is this is a pair that belongs together. So we are going to plot that coordinate. -4 to -13. We just had a little bit of recap on this. our coordinates. Oh, look, I need to go down there. Yeah?
If where you put the numbers, I wrote my own.
Oh, that's fine. Does it all fit on?
Yeah.
No, I
You have to draw one. You have to draw one.
Between the corners, yes. Join the corners up. So -4, -13, so that's going to be here. Now remember my board is a little bit out.
So it's okay if it's not all of the points in the.
That's fine. Yeah, because that's the scale we chose.
Okay.
0, -1, so that's here. Oh dear. Perhaps I should be doing it. Oh Lord.
You messed up? You messed up?
We did. What did we do?
You can't make 17. 17 goes on top.
17 goes up, doesn't it? And we're plotting the point 6, 17.
No, look, Miss Harrison.
6, 17. It's Miss Harrison what?
It's 0 and -1.
That is -1. It just doesn't look very good. It's about 16 inches.
Never mind.
Okay, so I found 0 and we went down to -1. Alright, now, there's our 3 points. We should see that we are able to join them up in a straight line. Okay? If for some reason they don't, it means that either your scale is wrong, or you've plotted something incorrectly, or you've miscalculated when you substituted.
Or you put in a different little space in the bars.
Yeah, or it means you've done something wrong. Okay, so that's our first one. We are going to do a similar thing for each of the next ones. Now, notice your graph, your scale is going to be different for each one. So don't go putting them straight in. I would suggest you may want to consider using numbers more like -1 and 2, but that's up to you. It just means you're not having to spread them quite so much. So you're going to draw the rest of your graphs now.